Hello, ladies and gentlemen. Time to continue with Module 3 notes. Today we're going to take a look at Module 3, Lesson 3, adding fractions with models. Adding fractions using models. Not dramatically different, but let's stick to the original title there. Okay. This is going to need a Roman numeral 3, so 1, 2, 3. Now in our last lesson we talked about common denominators. Well, we mostly talked about common multiples. Eventually you will be using common multiples to find common denominators to add and subtract fractions. But for today, I'm going to show you one other way using models, using pictures. That way you have a visual of what's happening. We'll kind of connect it to how we started Module 3. No new vocabulary necessarily, but we do have some key concepts I want to make sure that you have a handle on. The first one, we've discussed this in class. The denominator, and remember the denominator is down, the denominator is the number on the bottom of the fraction. The denominator is a label. Slash shows a unit. Now, what does that mean? Okay, it's a label. It shows a unit. It shows you a couple things. It tells you first, it tells you how many pieces came from the whole. And I know that is kind of how we defined denominator. So that especially should be familiar. It tells you how many pieces came from the whole. And this is the part that makes this not just straight vocabulary again. And how big each piece is. Okay. We've talked before, 1/4 is a different size compared to 1/3. They can both still come from the original whole, but 1/4 is actually going to be smaller than 1/3. The bigger the denominator, the more the pieces, the smaller the piece is. Okay. We're going to use it as a unit as we move on also. I'll show you when we start adding what I mean by that. All right, the second thing actually does touch upon that a little bit. I'm going to start with a phrase that I'm hoping most of you have heard before. Okay. If you've ever heard the comparison apples to oranges, or the phrase apples to oranges, what it's actually saying is we cannot compare the two. We cannot look at them and expect them to be the same because they're not. They're different fruits. Apples are red or green. Oranges are orange. Apples are usually crisp. Oranges are a little softer. Whatever, you get the idea. They're different. Okay. Well, pieces of different sizes, so essentially different denominators. Okay. If you have different denominators, okay, and eventually we're going to use the word unlike denominators, but I'll stick with different for now. Different, unlike denominators. Pieces of different sizes, different denominators, cannot be combined. Okay. Going back to the example from earlier, if I have 1/4 and I want to add that to 1/3, I cannot combine them the way they are right there. They're different sizes. They won't lock together correctly. Now, let's talk about one way that you can combine them, that you can put them together. So, looking at subheading B, let's get some procedure for today. Step 1. Step 1. Draw models for your fractions. Draw models for your fractions. So let's go ahead and begin with 1/2. We love 1/2. 1/2 is pretty easy to work with. And let's add that to 1/4. Okay. Now again, like we said above, these denominators are different. They are unlike each other. They are unlike denominators. So I have to try to make them the same. We'll get to that in a minute. First, all I'm going to do is draw 2 rectangles. I'm going to try to make these rectangles as similar as possible, because ideally they should be the same size. They're probably not, but we will endure. We'll get through this difficult time. Draw a line down the middle. We've broken this into halves, and I am going to shade in one of the halves. So here is my model that represents 1/2. Okay. Now I'm going to take a break real fast and just put a quick note here, because I noticed this while I was preparing the notes. I didn't do it this way originally, and it doesn't work if you don't. Make sure that you start with vertical columns. I'll show you what I mean. 1/2 is pretty easy. I just went straight down. There's a column. There's a column. Now normally when I'm making fourths, I started here and I thought, oh man, I can go right across because there's like... Nope. If you do that, this process doesn't work. Start with my 1/2. There's 2 pieces. If I cut each half in half, now I have a total of 4 vertical columns. Shade in the one on the far left. There's my 1/4. Okay? So you're going to go ahead and create a model. You're going to draw a picture of each fraction. Put a little adding sign, a little addition sign, since we're going to add them. Now step 2. Step 2 isn't hard, but I did have a little trouble putting it into writing. Okay, I had a little trouble putting it into writing, so please listen carefully to what I'm doing. We'll write down the instructions first, and then I'll show you exactly what I mean by this. You're going to add partner rows. You know what, hold on, stop. I want to be careful with that word, because that has a very strong meaning in math, right? We're going to add things. Let's draw partner rows. Sorry, folks, but I want to make sure I'm being very careful with the wording that I'm using. So go ahead and moan and groan at me and erase that. Let's write draw. Draw partner rows. Now, what this means is you are going to look at the other denominator. You're going to look at the other denominator, and create that many horizontal rows. This is why it was so important to start with vertical columns, because now we add the horizontal rows. Okay. Now normally you're just going to use the exact same model you already drew and we'd start going across that way. But again, I want you to be able to see the difference. So for our notes, please draw 2 more rectangles. I want you to be able to see the progression. I want you to be able to see how things are changing. So draw your rectangles. Start them just like you did the others. Okay. Here's my 1/2. Now shade lightly, especially for this next part. You're going to want to have it light. Okay. There's my 1/2. There's my 1/4. Now what I'm going to do is take a look and say, all right, this one has 2 columns. My denominator was 2. I am going to look at the other fraction, see that it had a denominator of 4, and now I'm going to draw 4 rows. And normally I would do it that way, but let's make sure I'm staying horizontal. Okay, so there's 1 row, well, technically 2 rows. 1, 2. Split. Split. 1 row, 2 rows, 3 rows, 4 rows. Just like we did in lesson 3-1, we are taking this model and we're finding an equivalent fraction. We split it up, which will help us find an equivalent fraction in just a moment. First, I got to go back over here. This was our 1/4. So for 1/4, I look at the other denominator, 2. That tells me I'm going to make 2 horizontal rows. So there's 1, there's 2. Okay. Now if I count these, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Even though the pieces look slightly different in shape, their size would actually be about the same, their area would be the same. The important thing is I have 8 pieces in each of them now. They each have the same number of pieces, which means I have found a common denominator. I have found a denominator that would be the same for both. So, for step 3, to wrap this up, for step 3, we're going to rename the fractions and add. See, now I can use the word add because now we're actually going to do some adding. Now, 1/2 plus 1/4. That's what we started with. But we now know that 1/4, or excuse me, let's start with 1/2. 1/2 is the same as 1, 2, 3, 4 eighths. I didn't change anything that I shaded. The shading stuff stayed exactly the same. But when I broke the pieces down, I ended up with 1, 2, 3, 4 out of a total of 8. For 1/4, 1, 2, 3, 4, 5, 6, 7, 8. Again, it's going to be over 8. We found a common denominator. But 2 of the pieces are shaded. Okay. Now, I can add these together. 4/8 plus 2/8. Now this is where we finally get to start talking about the denominator as a label. If I have 4/8, that means I have 4 of these pieces plus 2 of these pieces would equal 6 of those pieces. Now this is a very common mistake. A lot of students want to go ahead and add 8 plus 8 and get 16, but please don't do that. 8 plus 8, we're not adding the denominators. Again, these are labels. It's like inches. You wouldn't add 4 inches plus 2 inches and then come out with, I don't know, inch plus inch. You just carry the label over. 6/8. I had 4 of them. I added 2 more of them. Now I have 6 of them total. 1, 2, 3, 4, 5, 6 shaded pieces. The pieces are all eighths. Now, if that's not clicking, we're going to spend a lot of time talking about that, so it'll come. But for right now, the last thing I'm going to do, and this might be a little ahead of us, but I'm hoping you did this in 4th grade. Normally with fractions, we always want to simplify. We want to make sure they're in their simplest form, so we need to find an equivalent fraction that has a smaller numerator, smaller denominator. We do that by trying to think, what can we divide the top and the bottom by? What is a common factor for both? In this case, I can divide 6 and 8 by 2. I can divide each of them by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. These no longer have anything that I can divide them by. They no longer have a common factor. So this is our answer. Now I'm going to be a little less picky in the beginning because like I said, I realize that for some of you, this may be new, or at least, I don't know, might be a little rusty on it. We're going to practice a lot of simplifying. So if your fractions are not all in simplest form right away, I will try to go easy on that. But it is our ultimate goal. We do want to make sure we're simplifying those fractions. All right, ladies and gentlemen, we will practice this more in class. Now, there is a different way that we're going to use to add that requires fewer pictures, and hopefully, if you do it right, less simplifying at the end. But we'll get to that in a few lessons. All right, for right now, as always, write down any questions that you have, and I will do what I can to answer them in class. I will see you there. Thanks, everybody.